When you look at question number 9, they give you 4 expressions and they're asking you to compare them all to this one right here, the 4x squared minus 4x minus 120. So the math way to go about this question. So you're going to factor and basically see which ones are the same. Remember, when you are having trouble or if you need to, you can always use the box method to help you factor if you're getting stuck. If you can see question choice 3 has already been factored, there's nothing else that we can do. But in 1, we factored out a 2, then we factored out the remaining x squared minus x minus 30. That's where it came from. And after all is said and done, you can see that 1, 2, and 4 are all the same as the original. Now, the calculator method. This is a cool version. So if you get stuck on this question, don't fear. What you can actually do is graph every single one of these. Now, I went ahead and did this already to save some time in the video. And what you can see is I have graphed every single one. You can see that the original is what I have here written in like this orangey yellow color. And all of the graphs that were the same, the answer choice 1, 2, and 4, all line up. One thing that I would recommend that you do is actually do this yourself, because you might get an error message, especially with answer choice 4 here, if you forget to put a multiplication dot on your calculator in between the 4x and the x minus 1. Question number 10, you needed to set up a system of equations, and the giveaway was we didn't know how many large or small candles were sold. So that's where I brought in my x and my y. I came up with my total number of candles when I added the two together and set it equal to 20, because that's what the problem said. And I did the same thing for total cost. Remember, your unit should always be the same. So quantity, 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 money, money, money. And you're in good shape. Then I chose substitution. I got x alone and started rocking and rolling with it and ended up getting y is equal to 8. You could have also gotten y alone and solved for x. It just would have been a little bit more work. Now for the fun part. Since we have our calculators, all you had to do was use the system of equations solve feature. So let's go ahead and see that in action. So just as a reminder, you're going to go into the menu. We're going to do some algebra and solve a system. We have two equations, so you hit OK and you just type them in. And after you're done, you just push enter. It tells you x, the small candles, is 12, and 8, the number of large candles, is your y value. So that's why answer choice 2 is correct for 10. Number 11, there's not really a nice way to do this on the calculator, so right now we're just going to look at the question and figure out what's important. Well, here in 11, it asks which are functions. So in order to determine if something is a function, every x can only have one y value. So if you see repeating x values going to two different y values, that's your problem. That's why in answer choice 1, that's an issue. This is not a function because, and I would recommend that you write this out, the x value of 2 has two y values, 6 and negative 6. Again, 3 is also bad. It fails a vertical line test. You could also say that the x value of whatever this might be actually has two outputs. 2 and 4 are both functions because, well, 4 is just a linear equation, so this is just a line, so it's a line, so it is a function. And then number 2 is fine because 1, 2, 3, 4, 5, 6, 7, they all are not going to anything else other than one value. So therefore, the only ones that are functions are answer choices 2 and 4. Heading down to 12, they just wanted you to evaluate a function when you input 1/2 in any time you see an x. So remember, anytime you see something inside the parentheses, you're just putting that in. That's your input. That's your x value. If they had said f of x equals 5, then you would have set the whole thing equal to 5. So they're very different. Just keep that in mind. I just went through and I did the math here. Now, I think that for a question like this, if they do give this to you on the Regents exam in the future, it's definitely a gift question because I would recommend doing it completely all on your calculator. So let's see that in action. Make sure to use a pretty print fraction at the beginning, so hit Control Division. And then you're going to use the square root symbol to type in everything that you see underneath the square root. The biggest issue that you're going to have with this question is maybe typing it in incorrectly. So make sure that all of the numbers are in the right spots. Notice how I used that pretty print fraction key multiple times in this question. And then when all is said and done, you press enter and voila, there is answer choice 3. Question 13 asks you for the zeros, aka the solutions of this function. So in order to solve this, the first thing that I noticed that all my answers are integers, so this is factorable. So I am going to factor this. I see that there's a GCF. That's usually what people forget to do first, but I didn't, so we'll factor out a 3, and then we'll factor the trinomial, just like what we did a few questions back. I think question number 9, or yeah, I think it was 9, maybe 10. And you can use the box method if you need to. Then, of course, set it equal to 0, and then set each one of the factors equal to 0. So 3x minus 2 and plus 1 to get your roots, your solutions. Obviously, the first one doesn't make sense. 3 doesn't equal 0. So then you get x is equal to 2 and negative 1, which is answer choice 4. Okay, flip side, let's graph it because we have a function here. And once you graph it, you just want to find the zeros. You can analyze the graph. It's pretty easy to tell right now because they're nice integer roots. But here's one of them. I'm going through it kind of quick, but menu, analyze graph, 0, boom, boom, and there you have both of your roots at -1 and 2. So this could have been done entirely on the calculator as long as you know what zeros are. Question 14 is basically just testing whether or not you understand function recursive notation. This is bringing back the before, now, next lingo. So for 14, the first term, so F1 is equal to 10. We can get rid of a couple answer choices just because they have the incorrect first term. So 2 and 4 are out. That narrows it down to 1 and 3. A common difference of 4 is adding 4. So just by knowing that, you could pick answer choice 1. It can also be written to help you as the now is equal to the before, f of x minus 1 is before, plus 4. Number 3 would have been a geometric, yeah, that would have been a geometric recursive pattern, and we weren't dealing with a multiplier. We were dealing with something that was being added. This question wouldn't have been great to do on the calculator really at all, so we'll just skip that piece. Question 15, I would have been very sad if you did not set up tables in this one, because we're dealing with the average rate of change. We want to find the biggest one, so we're looking for the slope between 2 points. And they have 1, 2, 3, 4 different options to pick from. So here's all my work for this. There's not really much that you can do on the calculator. Just keep in mind, this is not 1,700. That is the point 1,700. And use the graph. It doesn't make sense that that would be 1,700. So be very careful. And then all you're doing is finding the change in y values and then dividing it by the change in x, and you're looking for the biggest number. You can also see on the graph that if it's the greatest average rate of change, we're just looking for the biggest slope. So where is it the steepest? The only one that you might be a little bit not sure about is between 1 and 2, but as you can see, if you look at the answer choices, it just gets a little bit flatter and flatter, meaning that the slope is just not as steep. With 16, you wanted to graph these, but I used my tables of values to help me. This is a piecewise function, so let's talk about how to graph it. You can graph them as 2 separate pieces. As you can see, I highlighted the domain because this is smaller than 1 and this is x is bigger than or equal to 1. So we have our absolute value function being smaller than 1 and our square root function being bigger than or equal to 1. But I think that using the calculator, so you're going to use the key of everything, which is next to the 9, to get the piecewise graph. We could use this one or the one next to it, but I only have 2 pieces, so I can use the first one. If I had more, I would. And then I'm just going to type this function in. If you need any of the symbols, use the key of everything next to the 9. push enter, and you can see that right away 2 of the answer choices, 3 and 4, are out, and then 1 and 2, actually no, it wasn't 3 and 4 are out. 4 is out, and it looks like, oh no, yeah, 3 is out too. I'm just losing my mind. Okay, so 2 and 1 are in. We're just looking for the square root function to look like this. And just by looking at it, you could also tell by looking at the table of values to make sure that they all matched up to the points that are on the graph. I didn't